New York's Manhattan Island, where the skyscraper rules the roost. Ever since the first one went up over a century ago, the drive has been to push towers taller and cheaper. But the resulting demands on engineers have created repetitive, predictable shapes. Creative flair and groundbreaking design were rare exceptions. That was until 2017, when in Manhattan's Tribeca district, a spectacular new tower was unveiled. This is 56 Leonard Street, where a team of engineers and architects stepped over the cutting edge, ripping up the skyscraper rulebook.
The shapes are extraordinary. I mean, boxes stacked on one another, and some of them are slid out. The whole thing looks so precarious.
At Leonard Street, 56 stories of unique apartments are stacked ever more daringly right up to its 250-meter summit. Here at the top, engineering logic seems to have been recalibrated to defy the laws of gravity.
It all just looks a bit scary.
Unique apartments with sky-high, impossible overhangs created a complex and expensive construction. So how did they build it? Even more than most cities, Manhattan is space-hungry, resulting in tall buildings with simple layouts that are a compromise between the engineering challenge of building a skyscraper and the practical economics of doing it at a price.
Most skyscrapers or tall buildings are either rectangular or tubular because those are really efficient shapes when it comes to supporting themselves.
For construction purposes, and developers like to have buildings be fairly regular, columns going straight up, etc., so that every floor is the same and they can just build it nice and quickly.
These uniform layouts are now so efficient to build that a conventional high-rise with over 50 floors can be completed in just weeks. But the results are often a little underwhelming.
Imagine you wanted to change things up a bit.
You could put this cantilever section in there, this box section in there, and you might even want to, like, take out bits. Oops.
Changing it up in the world of skyscraper construction means taking risks. But that wasn't going to stop developer Isaac Senbahar.
We knew this was going to be a very tall structure and very visible from almost every angle in the city. So we said, okay, we have a responsibility to do something iconic. We didn't want something repetitive, some just straight up building. We wanted something more interesting, more sculptured.
When Isaac bought the site in 2008, Tribeca was not one of Manhattan's glamorous residential districts. But building something special anywhere in New York is expensive. So these apartments would have to command top dollar. Needing a design that would attract the uber-rich, Isaac headed to Europe and world-renowned Swiss architects Herzog and de Meuron.
We felt that Isaac was ready for a new approach, a more radical approach.
Herzog and de Meuron's portfolio includes some truly incredible buildings, like Bayern Munich's Arena Stadium and London's Tate Modern Extension. But no skyscrapers.
Even if we had done a building before, a tall building, we would always look at it from a different angle and would give him something unexpected. We wanted to be a stack of apartments, but not an anonymous one. The building could be understood as a pile of individual pieces, even in the middle part, and then the top, which would have even more exclusive apartments, which we decided could become like stacked private homes. And I think that's really new and hadn't been done before anywhere.
There's good reason it's never been done before. In order to make a strong, stable, tall building, irregular spaces are normally built into the super-stable lower floors, with smaller structures at the top. The architect's concept that the higher the apartments are, the more off-balance they appear, flipped conventional high-rise engineering on its head. To pull this trick off at the top, they needed to reduce structural complexity lower down, while still making the floors appear to be different. To do this, they hatched a cunning plan. The first 46 floors would be built in the conventional way, using continuous outer columns and inner walls to provide support for the floors above. The floor layouts would also repeat, but they'd been made to appear different by changing the size and position of balconies and edges. The 46th floor would be unoccupied, and so could be packed with load-bearing walls, creating a 47th floor plate that would be a super strong, super stable platform for the rest of the floors above. Skyscraper specialist Hez Zimena was the engineer tasked with making it happen.
We tried to stiffen up the building enough up to the 46th floor, so when we reach the 47th floor, the first Sky Villa, the building will have sufficient stiffness that we can have the flexibility of doing whatever we want structurally and give the architect the freedom to do whatever he wants with the space.
And what the architects wanted was to create an extraordinary visual effect.
If you make this upper box, let's say, hover to a certain degree, you don't make it hover so it collapses. You can push it to an extreme, like in Chaplin's movie, where this house always is on the verge of falling down. Together with the structural engineer, you find the right moment between something fragile, something even dangerous.
That vision for off-balance apartments that still had wraparound views meant pushing structural concrete engineering right to the edge. The lower floors used conventional skyscraper engineering, where continuous columns share the load. But because the top 9 floors were all offset, that same system wouldn't work. Each of these floors had to be stiff enough to support huge cantilevered overhangs, some over 7 meters. And they had to do that without compromising the view from within. To pull it off, engineers turned to a 125-year-old idea: the Vierendeel truss. A regular truss uses diagonal cross members to create triangles that make it very strong both laterally and vertically. But the views from within would be ruined. A Vierendeel truss connects the 2 floors using only vertical columns, so it's just as strong vertically, and it keeps its lateral strength through the massively strong central lift shaft column that also connects the floors. So the Vierendeel truss allows huge openings, and the apartments above can be offset with crazy overhangs.
A Vierendeel truss is actually a brilliant solution for a long cantilever. They were developed by Alton Vierendeel, a 19th century Belgian engineer who developed the super strong truss, particularly resistant to bending forces. The advantage of utilizing a Vierendeel truss is that it's not obstructive architecturally. Like traditional truss would have a diagonal member crossing through the space, and that would be very obstructive architecturally, and it's kind of prohibitive. So we came with a different approach.
So this is how the Vierendeel truss became the key to building the Sky Villas. On super-stable floor 47, concrete columns are precisely placed where they will give support to the floor above. This creates the first Vierendeel truss. The central lift shaft provides all the lateral strength, so the floor remains beautifully open plan, but can still support the tremendous downwards forces from the 8 unique stories built on top. These trusses create such rigidity that the upper floors don't have to sit directly on top of one another, allowing the amazing overhangs. All helping to make the Sky Villas some of the most spectacular homes in the world.
There's literally nothing underneath us other than the slab, and then it's straight down to the street level, 800 feet below us.
Not only are they over 200 meters up, but at up to 550 square meters, the 9 Sky Villas are huge, each exclusively occupying its own floor and each with a unique layout. Situated in up-and-coming Midtown Manhattan, it was hoped homes here would fetch sky-high prices.
This is a building aimed at some of the wealthiest people in New York.
The lower apartments up to the 45th floor would be priced between $3 million and $10 million, while the plan was the Sky Villas would sell for over $20 million. And those hefty price tags were needed, as it became clear the top 9 floors, with their unique layouts, were going to be slow and expensive to build.
You know, you do 3-4 floors of all the same thing, and then you're used to it, then it's just automatic.
But of course, Herzog's 9 Sky Villas were all unique.
Every floor plate is a different size and shape.
So every floor was kind of, there was a learning curve. And then you learn that, and now it's a new plan. It's just like, you know, the game changed every time we poured.
Because each of the Sky Villas is different, before work could start on the apartment above, the one below needed to be strong enough to support it. And that meant more time for the concrete to set.
The biggest challenge for the contractor is to hold the forms and the scaffoldings in place until the concrete cures and reach its required strength, and then he can remove the scaffolding and the temporary supports.
You know, in New York, we used to pour 1 floor every other day. Here, some floors took 6 weeks.
By 2014, the lower 46 floors had taken 20 months to complete. And with the top 9 floors set to take 9 more months, extra measures were taken to make the site safe and weatherproof.
It was actually very interesting to see during construction that it had this black curtain protection around the entire 10 floors. Once everything cured, they start stripping down the scaffolding, and then this beautiful structure, it's almost like a sculpture, revealed itself to the public.
So, with patience and engineering ingenuity, the impossible overhanging Sky Villas had been created. But before anyone moved in, the building needed protection from something that spells trouble for any skyscraper: the wind.
Tall buildings will always move in the winds, and that can't ever be completely stopped, and they'll always move, in some cases, by quite a lot.
New York has recorded winds of up to 100 miles per hour, and Leonard Street's sheer height and comparative isolation from other scrapers means in high winds, it can move by up to a foot at the top. It's engineered to handle this amount of flexing, but left unchecked, these movements can keep on increasing, potentially collapsing the building. So it's crucial there's something to counteract these forces.
A lot of skyscrapers have what's called mass dampers. They're basically counterweights. So for example, if the wind is pushing one way, the counterweight pushes the other way.
Most skyscraper counterweights are large suspended blocks like this. But at Leonard Street, they chose a damper system sometimes used to cope with the ultimate threat to buildings: earthquakes. Skyscrapers in earthquake zones have water tanks to cope with the swaying induced by a massive quake. This is what 56 Leonard Street uses.
At the top is a giant tank of water. When the building moves one way, due to the wind, the water in the tank moves in the opposite direction.
So 56 Leonard Street was ready for the forces of nature. But in 2016, just a year from opening, the engineers needed to get the inside prepared for new residents. To do this, a twist was given to an otherwise ordinary feature: the lobby staircase.
You have a stair, so do the stair in a way that it's nice to walk up and down. It's inviting, I would say, to take the stair, if it's 1, 2, 3 floors perhaps.
As usual at 56 Leonard, the stairs would be made of poured concrete.
So the way to design something in concrete, it's called formwork, and it's really simple. It's basically just creating a mold of whatever shape you want and pouring the concrete in, letting it dry, and there you have it.
Sounds simple. Except when the pour involves nearly 50 tons of concrete, and the architect is demanding a seamless finish for his stairs. A seamless finish is created by not letting the concrete set between pours, so preparations needed to be meticulous.
5 months to plan the stairs and create the mold that the concrete would be poured into.
It started with experts conducting the whole pouring because concrete has air bubbles in it, and that's why they use vibrators. This guy was conducting everybody where to use the vibrator. It was a very, very precise operation and a long day.
The carefully poured staircase was typical of the attention lavished on every inch of this building. Once finished in 2017, the quality of Leonard Street was obvious. But potential buyers had understood this was a special building way before that. Sales had opened in 2013, and almost immediately someone agreed to pay $47 million for a sky villa. A record for any address below Midtown Manhattan, and a sign that the risks taken by its developer would pay off.
I think we broke a record. We sold close to $1 billion in 9 months.
2.5 million man-hours, 27,000 cubic meters of concrete, and 5,000 tons of steel went into creating Leonard Street's 46,000 square meters of space. It had taken over 5 years, but a towering landmark now graced Manhattan's skyline. And if proof of its success was needed, locals have affectionately given 56 a nickname.
Someone spoke of the Jenga tower. At the beginning, I didn't even know what he was talking about. But people like it, and if people like it over a certain time, this is a good sign.
It was difficult. It was 10 years of my life. But to build a building like that in the skyline, it always feels good that, you built something like that.
56 Leonard is remarkable. I mean, it stretches the limit of what's possible to build, what's structurally possible, and then celebrates that.